Hello everyone, welcome to today's lesson on linear systems by elimination. Right, so last time we learned about solving systems of linear equations by graphing. This time we're gonna do it by a method called elimination. Right, so this is the method I like to use the most because this is just pure algebra. Right, but again, like I said last time, just use whatever method that you like the most. Okay, so generally we want everything to be in a general form. Right, ax plus by equals to c. And what we want to do, our goal is to cancel out one variable, right? Because in order to solve for our equations, we always want one variable for one equation, right? Because if we have one variable in one equation, we can just isolate it and then figure out from there. If we have two variables in one equation, we can't really solve it, right? Because you have to isolate for one of them, right? And this step here just tells us, this step here is telling us that right, if we cannot cancel it out, we gotta multiply it in order to cancel it out. Right, but a lot of that can be explained using examples. So let's take this first example here. Right, we notice here we have a plus y and a minus y, which means that if we just add those equations together, we can cancel the y out. Right, because if we have something like this, right, if we can imagine just adding both those equations here. Right, we get x plus x, which is 2x. But notice here we have a positive y minus a y. The y here actually just cancel out, right? Y minus y is just 0. And the constant adds up to 10. And then from there, we went from two equations and two variables to one equation, one variable. And that's it. With one equation and one variable, we can just isolate for the variable. Divide both by 2 to get x equal to 5. Okay, now we found out x, let's find y. To find y, all I have to do is plug it into an equation. Alright, we can pick either of those equations, doesn't really matter. Alright, so now let's just plug this 5 into the equation to find y. Alright, 5 plus y equals to 6, so y here must be 1. Okay, and that's it. X is 5, y is 1. Yeah, that's it. Right, doesn't actually matter which one you plug in, right? If we put x equals 5 into our second equation here, right, we get 5 minus y equals to 4. Right, y still equals to 1. Right, and we can always just double check, right? X is 5, y is 1. Let's check it out. If x is 5, y is 1, that equals to 6, check. X is 5, y is 1, subtract equals to 4, check. Okay, so if you're ever unsure, you can always double check your work by plugging x and y back into both equations to see if they still work. Okay, second example. Right, once again, want everything into general form. Right, so we can subtract x from both sides on the top, and add 5 to both here at the bottom to convert those into general form. Right, x plus 2y equals to positive 5. Right, always want x plus y equals to constant. Right, it doesn't always have to be plus. Remember, it can always be minus. Okay, and once again here we can add again, right? If we add both of those equations, we notice here the negative x plus the x, that makes the x disappear, leaving for the y, right? Y plus 2y is 3y equals to the constant of 9. Right, so from here, y must equal to 3. Right, then we just plug this y back into one of the equations. Right, doesn't matter which one you plug in. You can plug into the rearranged or the original. Right, again, it's just the equation is just rearranged, so the answer is not going to change. So let's just plug into the original then. So y equals x plus 3, and we know y is 3. So x here must be negative 1. Alright, so negative 1, x is negative 1, y is 3. Okay, and that's it. Alright, so keep in mind, we can also write the answer as ordered pairs, right? This is just 5, 1. This is negative 1, 3, right? If we graph it, this is the point where the two lines will intersect. Right, again, I will take both as an acceptable answer. Because again, they're just different ways to represent the answer. Okay, how about here? Now, unfortunately, we cannot just cancel anything out, right? Even, let's say, if we were to subtract this, we will still have an x left over, right? We cannot just subtract it right away to cancel it out. But what we can do is to multiply everything here by 2. Right? Because if we do, right, if we multiply everything by 2, we realize that, okay, right, now we can actually cancel the 2x's out, right? Because instead of adding, if we just subtract it, right, those will cancel out, leaving us with one variable and one constant, or one variable and equation. Right, so just make sure that when you are multiplying it in order to cancel it out, make sure that everything is multiplied by the same number. So this is still the same equation. 3y minus plus 4y minus 7y, 2 minus 16, negative 14. So y is 2. Okay, plug that guy into our original equation. 2x minus 3 times 2 equals, oh, okay, don't want to skip steps here. That's our original equation. Okay, so 2x minus 6 equals to 2, which is 2x equals to 8. Okay, so x is 4. Our answer, x equals to 4, y equals to 2. Done. Okay, so yeah, our goal is also to cancel out one of the variables. If it doesn't cancel out nicely, we can multiply it so it cancels nicely. So here's a good example. Right, we cannot just multiply one of them now to cancel out nicely. But what we could do is using the lowest common multiple. Right, let's say I want to cancel out the x. So what I can do is now multiply the top by 3 and multiply the bottom by 4. Right, this is just like adding fractions. Because if we do that, if we multiply the top by 3, and oh, remember everything needs to be multiplied by 3. Multiply bottom by 2. Right here, notice how now we can cancel out the x again. Right, so we have to multiply it in order to cancel it out, no matter what. Right, so right here, 9y minus, or 9y here minus negative 8y. This is 9y plus 8y, 17. 15 minus 32, negative 17. Oh, look at that convenient math. Why is negative 1? We can plug into our original equation. You can also plug it into the equation after multiplying by 3. For x equals to 8, so x is 2. So x is 2, y is negative 1. Right, so as you can see here, right, we can just graph it out and find the same answer. Okay, how about fractions? Right, personally, I don't like fractions, so let's cancel everything out, right? We can cancel out the top by 12 and the bottom here by 72 by multiplying it. Because if we do, we can actually cancel all the denominators and get the numerators left over. If we multiply everything by 12 up there, we get 6x minus 3y equals to negative 7. Right? We can now multiply the bottom by 72 to get that equals to 0, right? 0 times 72 is still 0. From there, we can see, oh, okay, look at that. We can just actually multiply the top by 2 to cancel out the y. Right? We could, again, right? We could alternatively multiply the top by 9, multiply the bottom by 6, right? So we can cancel out the x. However, that's too much work. I don't like doing too much work. Right, so multiply the top by 2. The bottom stays the same. And now we can add them, this time to cancel out the y. So we got 21x equals to negative 14. Right? So x is negative 14 divided by 21, or negative 2 over 3. Right? We can now plug this right into the original equation, but that's too much work. That's fraction divided by fraction. I'm too lazy to do that. So we can just plug it into one of our equations here. That doesn't actually matter which one you plug into. They're all the same anyways. Okay, right. This cancels out to 1 and 4. Minus 8 minus 8y equals negative 4. Right, plus a to both sides. 4. Oh, hold on a second. That's not 4, 14. Plus h should be negative 6. Y just negative 6 divided by negative 8, which is positive 3 over 4. Right, so x is negative 2 over 3. Y is 3 over 4. Okay, just like that. Note that here, right, we notice here that we don't actually have to cancel all fractions out, right? If we multiply this by 3, right, this will cancel out to 1 and 3. And then from there, we can actually cancel out the y here. Right? So we can easily just do that as well if you want to. Right? But personally, I don't like fractions, so when I see them, it's a bit extra work to cancel all the fractions out. But again, for me, it's makes me less prone to mistakes because I suck at fractions. But again, no matter what way you do it, as long as you multiply everything by the same number, right? That's all fine. Okay. Here are 2 suspicious examples here. Right? Oh, those look a lot easier than fractions. What's the gimmick here? Okay, first of all, good on you for doubting me, because you know, math is all about seeing the different patterns, right? We can multiply everything by 2 to try to cancel out the x. Uh-oh, what is this? This looks kind of sus. Right, if we add those together, we got 0x here, but also 0y here, with a constant 4. Right, oh, sorry, that should be a 5. Should be a 2 up here. Oops, didn't multiply everything. Right, what is this? 0 equals to 5. Right, what does that even mean? 0 equals to 5. That means there's no solution. Right, if we were to graph those 2 lines out and find a slope, we'll notice that they're the exact same slope, but they're parallel. Alright, lines are parallel. Okay, so if we have 0 equals to a number, something that doesn't make sense, then that means there's no solution. Alright, let's try another suspicious example here. Alright, look at that. That looks way even worse, right? What is this? Alright, we can add them up. What is this? We got 0 here, right? 10y minus y, 10y, 0, 4 plus minus 4 is 0. So now we have 0 equals to 0. What is this? That's even worse. If we get something like this, then that means we have infinite solutions. It's the exact same line. Right? So the 2 lines here must coincide, or literally on top of each other. Because if we see here, right, if we actually multiply the top by negative 2, right, we see here that if we multiply the top by negative 2, it's the exact same line as the second line here. Alright, so that's why 0 equals to 0, because literally everything's the same. Alright, so whenever we do elimination, when we get 0 equals to 0, that means it's infinite solutions. And when we get 0 equals to a random number, that means it's no solution. Okay, so that's elimination, a bunch of algebra. Right? But again, the nice thing about those is that if you ever want to double check, just plug the x and y back into both lines to see if they make sense. Okay, but that's pretty much it. So, good luck practicing.